This quadratic ax squared plus bx plus c equal to 0, like I said, has roots x equal to minus b plus minus root b squared minus 4ac by 2a. These are the roots of this quadratic. If I took the plus sign, let me say I'll get one value of x. One value of x is alpha. Let's say obtained by taking the plus sign, which is minus b plus root b squared minus 4ac by 2a. The other value of x can be obtained, let's say, by taking the minus sign. Call it beta. Beta, which is minus b minus root b squared minus 4ac by 2a. Right? Now, very clearly, the critical entity here is b squared minus 4ac. It's important to understand what this number stands for. B square minus 4ac, this is the quantity inside the square root. And if this quantity turns out to be negative, then square root of a negative number, if this quantity b square minus 4ac turns out to be a negative number, then square root of a negative number is not a real number. Square root of a negative number will not be a real number, it will be a complex number. It's going to be referred to as an imaginary number, which means if b squared minus 4ac is less than 0, then square root of a negative number, this then is a negative number, the square root of a negative number cannot be a real number, which will cause alpha and beta to be complex. Alpha and beta will not be real. Alpha, beta, not real. Assuming A, B, C are real numbers, not real. Alpha, beta will not be real numbers. Yes or no? If b squared minus 4ac is greater than 0, no issues, this is good. Because if b squared minus 4ac is greater than 0, square root of a number greater than 0 is a real number. Alpha, beta then will turn out to be real. This will cause alpha, beta, the roots to be real. Yes or no? And if b squared minus 4ac is equal to 0, if b squared minus 4ac is equal to 0, then this and this are both 0, then alpha will be equal to beta and each will be minus b by 2a. This would cause alpha to be equal to beta and each will be minus b by 2a. That means now the roots will be real and equal. Real and equal. I am assuming A, B, C are real. So if b square minus 4ac is greater than 0, alpha, beta are not only real, but they are also distinct. If b square minus 4ac is equal to 0, alpha and beta are equal and real. If b square minus 4ac is less than 0, then the two roots of this quadratic would be imaginary or complex, not real roots. That means this quantity b square minus 4ac is an extremely important number for us in terms of this quadratic, which means that I should give it some importance. Let me at least give it a name. This b square minus 4ac is commonly designated by the symbol d and is called the discriminant of the quadratic. Is commonly referred to as the discriminant of the quadratic. This is called the discriminant of the quadratic, right? If d is greater than 0, as is the case here, then the roots of the quadratic would be real and distinct. If d is equal to 0, If b square minus 4ac turns out to be equal to 0, then the roots will be real and equal. If the discriminant turns out to be less than 0, roots would be imaginary or complex, right? So, given a quadratic, at the very onset, just by looking at the sign of b square minus 4ac, you can infer a lot of things. Yes or no? So, for a quadratic, ax square plus bx plus c equal to 0, the number b square minus 4ac is extremely important. It's referred to as the discriminant of the quadratic, which on being greater than 0 will give me real and distinct roots. On being equal to 0 will give me real and equal roots. On being less than 0 will give me imaginary or complex roots. Thank you.